Look at this problem. R3N plus, here there is double bond. Okay, HBr is there. HBr, it will cut into H plus and Br minus. Okay, and here this compound will undergo electrophilic addition. Electrophilic addition means what? Addition reaction means what? Cutting the double bond and introducing these two groups across the carbons connected by double bond. Okay. Now we have to see whether this bond will shift this side or this side. The shifting of the carbon bond, if it is normal ethene, it can shift to any of the carbons. But here, due to the presence of positively charged atom on the adjacent, on the presence of positive charge on the atom adjacent to carbon, it is more likely that the bond will shift here because the negative charge on this carbon is stabilized by the pulling effect of this group. See, we have seen that whenever charged intermediates are formed, if there is scope of some reduction in the charge due to the presence of the adjacent groups, due to the help of the adjacent groups, then that particular ion will be more stable. That particular intermediate will be more stable. And the product will form through the formation of that particular intermediate. So the shifting of the pi electron towards this carbon is more favored because the adjacent atom has a positive charge and it pulls the negative charge towards it and stabilizes the intermediate. No. When this moves over here, the positive charge will be formed here. Okay, but when it moves this side, on this carbon, if there is a positive charge, adjacent atom also having positive charge, like charges closer to each other, then the intermediate will not be very stable. We have to see the stability of the carbocation. So the carbocation that is formed has a positive charge here. It is well separated from the other positive charge existing already. So the positive charge will form on this carbon. So negative on this. So when negative charge forms on this, the positive end from here connects here. And the negative end connects here. So what product are you likely to get? R3N plus. So H is connecting to this particular carbon, right? So this product is the desired product, major product. Got it? And what about this? Correct order of homolytic bond dissociation energy of homolytic bond cleavage means equal distribution of electrons between the bonded atoms. When is it more possible? When there is less electronegativity difference between the bonded atoms. Okay, then homolytic cleavage is more favored. And the number of bonds around a particular atom undergoing homolytic cleavage, okay, that should also be less. So that way, when we see methane, we have carbon surrounded by 4 hydrogens, smallest molecule. Smaller the molecule, easier the homolytic cleavage. Here C2H6, CH3. So 2 carbons are there. So the energy required for homolytic cleavage is slightly greater. And CH3Br, there is a more electronegative atom. So this bond, the scope for homolytic cleavage in this is very less. So we have to force it to undergo homolytic cleavage by applying more energy. So the order of cleavage will be homolytic bond dissociation energies. The least energy required will be for methane, A, and then ethane, and then CH3Br. So this is the order. Understood?